Thanks for attending this Fortify Unplugged session about Security Assistant. This is Rick Tasker, and I will turn this over at this time to the Product Manager, Jimmy Rabon.
Just to give you guys an idea of where Security Assistant fits into kind of the overall software development lifecycle, this is a part of our shift left. So it is in the IDE, and in particular, the Security Assistant's first supported IDE is Eclipse. But we obviously have plans to bring that to other IDEs. But the presentation today will be all in Eclipse and Java-based. It's designed to provide highly accurate, real-time results to developers to fix issues. It's meant to be an assistant while you write code, require almost no configuration at all, and no real training to use, and provide you valuable security information while you're developing applications. The idea being that these high confidence issues introduced as early as possible will allow the developer the easiest possible experience in terms of remediating them early in the lifecycle before they hit any of the later in the lifecycle activities like certification and accreditation, or even providing the developers the power to find vulnerabilities before they check their code in and have a full build performed. So in terms of installation, installation is very straightforward in terms of the same methodology that you use to install plugins for Eclipse today. You simply obtain our Eclipse plugin for Security Assistant zip file from the Fortify software package, where all Fortify software is provided. Unzip it, and then you just go into Eclipse, Help, Install New Software, Local, and you choose the plugin directory. Once that, you basically hit Next and install it. The only thing to do is to just check for the latest security rules. Security Assistant does take advantage of a subset of the same rules that we provide from our software security research team that powers our static code analyzer solution. And so the valuable rules they provide there also power Security Assistant as well. Once you have that, you're off and running. Just a quick lightweight look at the overall interface, and we will have a demonstration here at the end of the slide deck, but this does show you the menu, the icon, the identification of an issue, the identification of issues in the below pane under Security Help, and I'll show you as I walk through how it identifies issues and then how it provides you the details of that vulnerability and the remediation advice to do so. This is just a quick look at the overall found issues for Security Assistant in terms of where it's presented. It does use the same critical high, medium, low folders that are based on likelihood and impact provided by our security research group. It does provide the same rich details and explanations and recommendations. So all this information is provided from the rule packs and is also provided in Security Assistant, just like you may be familiar with our full offering with Static Code Analyzer. The categories of issues that we include by default that are checked here, you can see this in the interface. They've been tested by our security research group to be the most effective with Security Assistant. So you can enable other rules, but the rules that we enable by default were shown to have the most accuracy and provide the most value. So those aren't chosen haphazardly. They're tailored for the Security Assistant analyzers that were written specifically. For those of you familiar with Static Code Analyzer and the analyzers that are written for it, like configuration and data flow and structural and semantic and those types of analyzers, Security Assistant has two of the same type of analyzers that Static Code Analyzer has, but they are written specifically with providing real-time results and the speed and efficiency that Security Assistant requires to provide results in less than a second as developers write code. We'll talk about those analyzers specifically, but the types of rules that we enable are specific to those analyzer types. So these were chosen for very good reason and researched and tested. You can see here, this is just a continuation of the categories that we can find. We do not intend this solution to be an SCA replacement. We intend it to be an augmentation and a faster, easier to use, earlier in the life cycle tool that developers can use in IDE to find issues very early with as little effort as possible. And as we get to just a few additional information that'll, I think, be really helpful to users of Security Assistant, the results are provided in real time for specifically Java classes. That means that non-compiling artifacts, like if you think about a traditional Java EE web application like JSP, JavaScript, XML, those today are not supported. So you're only going to find issues that are actually written in actual Java code today. So if you are testing Security Assistant now, it's very helpful to know that in terms of what your expectations can be about the types of vulnerabilities we can find. We have a lot of plans for Security Assistant. This is the first version of it. We have many plans to make it much more robust and to expand the offering, but today this is the value that it brings. The analyzers that I spoke of earlier, intra-class data flow, meaning within a single class. So if you write, let's say, a cross-site scripting or introduce a cross-site scripting vulnerability, and the source of untrusted input and the sink of the dangerous execution point all occurs within a single class, Fortify Security Assistant can find that in less than a second. But if it's inter-class data flow is required to determine the vulnerability, that's something that today you would have to leverage Fortify SCA for. So that's a limitation. Obviously, certain caveats have to be made, or in terms of speed, to deliver results in less than a second. But the idea is that those types of issues will be caught at the build where a full SCA scan is performed in most organizations. So it's just those two specific analyzers, and obviously the rules that are written for those specific analyzer types. So semantic analyzers, the key, basically in terms of keywords, those types of rules are enabled as well as the intra-class data flow. To my knowledge, we're the only lightweight, Security Assistant-like tool that can actually do data flow, and we are obviously looking at ways to potentially expand that to inter-class data flow in the future, while still keeping the same delivery method that we use today. Certain taint flags are turned off to produce higher confidence findings. The idea is for Security Assistant to produce high confidence issues. So we're not as worried about false negatives as we are in the Fortify SCA world. We're more interested in providing higher confidence findings that a developer will find relevant. You can, however, modify the flags that we have turned off. We provide a filter, a config file here, taints.filter, if the user wishes to enable some of the taint flags we've turned off by default. That's in order to make the tool more accurate. The security research group determines certain taint flags to turn off, but the user is free to try to increase the power of Security Assistant. They wish to learn about all taint flags, though there is a likelihood of the tool being a little bit noisier. Kind of the idea behind Security Assistant is if your spell checker was wrong 6 times in a row or 2 times in a row, you might just turn the spell checker off. So we're very cognizant of being very accurate.
And we come to the demo portion of this Unplugged session for Security Assistant. What you're looking at here is the latest version of the Eclipse Integrated Development Environment, Oxygen. The tool, the whole idea behind it, right, is to provide real-time feedback as you type code. So we want to move application security as far left as we can. And Security Assistant is designed to be a lightweight tool to find issues as we type. So it finds much less than Fortify SCA does, but does so with almost no effort, which I will demonstrate during this demonstration. Here you see I have a kind of standard Java enterprise application. WebGoat is a sample most of you are all familiar with. There's a number of security vulnerabilities in WebGoat. So we have a couple of options with Security Assistant to start with. We can choose to inspect the entire project, meaning take a look at all of the source that is available throughout the entire project and find any issues that Security Assistant can find with its lightweight analyzers at one time, right? That's great for existing projects like this one, and I'll demonstrate that. And we'll also show you kind of the main use case of Security Assistant, which is it finds vulnerabilities as you type code. So as you never actually have to hit scan, just as you type code naturally, it will identify vulnerabilities as you finish the line of code. It will analyze that and immediately give you feedback. So we'll start with taking a look or inspecting the entire project, an existing project with Security Assistant. We can do so by just simply selecting the project in Eclipse's Project Explorer, right-clicking on that, and choosing Inspect the Project. So we're going to inspect the project, and then you'll see here in the bottom right-hand side, it's going to rebuild the project, and it's going to go through and inspect all of the security vulnerabilities that may be present in WebGoat. We can go ahead and click this to show you what we're doing. And the very first time you run this, we parse in all of the rules that are necessary. So it takes a little bit more time the very first time you run this. And you'll see here we're parsing through all of the different rules that may be applicable for WebGoat. We'll give that just a second here. And all right. So the rules have been parsed in, and now we're traversing the application. This is around 10,000 lines of code. And we can see here that Security Assistant, like that, has found 20 potential security vulnerabilities. We have 11 criticals, 3 highs, 4 mediums, and 2 lows. Those Fortify priority orders are based on impact and likelihood. So the critical issues are the most likely to be true positives, as well as having the most dangerous impact on the code base. So if we simply click through these, we can click an issue, and you will see highlighted here that we have a number of cross-site scripting persistent issues where we're sending unvalidated data to the web page here in a table cell. We can go through and click to other source files. Here we can see the issue that we have where we're sending, again, to another table cell some unvalidated input. So if we hover over this, you can see it shows you this is a security issue. And if we hover over the issue itself, you're presented with critical security issue, cross-site scripting, persistent, vulnerable code. Click the item to see more details. So when we click that, you can see the security help is present. And this is one of the nice things I want to point out to you about Security Assistant. We have a long history in static analysis with our static code analyzer product. And we are leveraging a subset of the same rules that we use for normal deep dive static analysis. So the explanation, the recommendations, and the references around each of these vulnerabilities all come from our security research group. And Security Assistant will continue to get more robust over time, just the same way that Fortify SCA gets more robust over time with rules. So here we can read an explanation of what cross-site scripting is, specific to this issue, the data coming in at line 109, the data being sent to the web page at line 169. We can scroll through the entire content here. We can also make this full screen if we would like, seeing all the references and standards here. We can click on the recommendations and see the full recommendations for fixing cross-site scripting, which is a combination of validating input and encoding for the proper context on the output. So kind of everything we need to kind of understand this vulnerability, as well as any of the references if we want to learn additional information about the vulnerability. So we can collapse these and simply traverse the issues. Here we have a hard-coded password. Right? We can see here we have a legitimate hard-coded password that we found. Let's take a look at the real-time capabilities of Security Assistant. Now that we've seen kind of what we can do from an inspection of the entire solution, let's take a look at what it does when it finds something in real time. Let me make this a little bit bigger. So I'm going to edit this code. I'm going to take away the semicolon. Right? And you'll see that the Fortify icon has disappeared. Right? So Eclipse has a number of issues with this, but Fortify no longer has an issue with this. Right? So the security vulnerability was removed from the bottom there. If we add this semicolon back, right, you can see that we have a vulnerability here present. Let's go to this guy right here. Adding it back, finding the issue again. And if we go to, let's say, one of these guys, we can add it back. So we are immediately finding the vulnerability as we go through. Right. Right, and there it comes back. So we are able to, in real time, find all of these issues. So if we were typing this line of code, we would immediately find it. We wouldn't have to hit the inspect. The inspect is only if you wish to scan the entire code base. If we come in here and go to the menu, we can come down to Configure Security Assistant. And these are all the rules that are enabled by default. You can add additional rules, but we have carefully curated a subset of our rules in which we've seen the most performance. Security Assistant is designed to not be annoying to a developer. The idea being that these rules have proven to be reliably accurate, right, in the detection of vulnerabilities. And so you can enable the additional rules, but you will see a little bit of noise come in to the product if you enable all of the rules. I would suggest sticking with the default rules as they were selected for a reason. And the idea being that if you need a robust scan, you simply do so at the build step, or you can use our full SCA plugin for Eclipse to do a deep dive static analysis scan that will take however long it takes to run a full scan. This is enabled or designed basically to find a subset of those issues very quickly so that you can fix them as you type them, the same way you would fix a syntactical error in Eclipse. Think of it as a security spell checker, there to help you, not to be annoying, there to be very accurate, and designed to help you build more secure code very early in the life cycle with very little effort. So you can see here we have the ability to enable or disable any of these rules. We can always open the security issue list, which is present here if you've closed it, and we can update the rules through that update button that you just saw there below the security assistant issues. So this will continue to get better over time. We historically release 4 rule packs per quarter, but that's the idea behind Security Assistant, to analyze an entire project with our specifically designed analyzers for speed and accuracy, with the intra-class data flow, and this semantic analyzer, and the ability to, in real time, find vulnerabilities. Thank you very much.